Hello, so now we're going to do trapezoids and kites to finish off our quadrilateral unit. So to start with, trapezoid, the definition for that is that you have you have one pair of parallel sides. Okay, so we just have one pair parallel sides. You can't have two pair, that would be a parallelogram. So you only have one pair. Now the actual parallel sides have names. They are called the base. So that's a base, and this is also a base. Now an isosceles trapezoid, so remember isosceles we've seen before with triangles. Isosceles triangle has two congruent sides. So when you have an isosceles trapezoid, you also are going to have two congruent sides. Now, because it's trapezoid, we have these parallel bases, but then the unique part is that the other sides are congruent. So you have two congruent sides. Now, the vocabulary for those sides are actually called legs. So we have bases and legs. We have bases and legs. Okay, but the unique part of an isosceles trapezoid is, so you have the two parallel sides from here, and we have congruent legs. Okay, next one is a kite. So a kite looks like this. These two sides here are congruent, and then these other sides are also congruent. And that's what defines a kite. Now to actually describe that, it's kind of difficult. So we have two pair of congruent, but they have to be in a particular spot. They can't be across from each other because then it would be a parallelogram. They have to be next to each other. And remember, we use the word consecutive for that sometimes. So two pair of congruent consecutive, that's an E, consecutive sides. Now, the other just really nuanced part of this is that all four sides can't be congruent either, because then it would be a rhombus. Okay, so you have two pair of consecutive congruent sides, but not four congruent sides. And that is the definition of a kite. Okay, next we have special properties about the angles of each of these shapes as well. So for the trapezoid, we have these parallels. So what that means is the parallels will give us a relationship between these two sides. So if you remember from last chapter, or the chapter before, same side interior angles are supplementary. So this is something we've used on lots of occasions. But if I put an example in there, let's say if this was 100 degrees, and these are my parallels, my bases, I would know this other angle here would be 80 degrees adding up to 180. If this angle was, for example, 120, then this base angle would have to add up to 180, which would be 60. So these add up to 180 and these add up to 180 because those are same side interior angles. Okay, same thing for the isosceles. So because you have the parallels, these are going to add up to 180 and these are going to add up to 180. So you have this part that also applies, but we have an extra piece of information, which is the base angles are congruent to each other, and the other set of base angles are also congruent to each other. So base angles are congruent. Okay, next we have, again, the kite. So I'll mark the kite as a kite. And then a couple of things here, vocabulary-wise, the vertex, or the corner where the congruent sides meet, is it called a vertex? And the other one also a vertex. So you have a vertex and then another vertex. So if I were to draw this diagonal in, there are two things I can write. So one, the vertex diagonal, that's what that's called. So the vertex diagonal bisects the angles. Okay, so what I can mark in the picture, maybe I'll do it with a different color, but bisects means these two angles are congruent, these two little ones, and these two other little ones are congruent. So I marked these with just the one curve and these with both two curves. Okay, and then there's one more thing you can say for a kite. The non-vertex angles, that's an N, non-vertex angles, maybe I'll use an abbreviation this time, are also congruent. So maybe I'll do that one in red, but the non-vertex angles here and here are also congruent. Okay, the next part is diagonals. So in a regular trapezoid, a normal trapezoid, we don't have anything special. There's nothing special about the diagonals. Pretty boring. But when we get to an isosceles trapezoid, the diagonals are actually congruent. So if I was to label this, for example, remember when you label a polygon, you need to label it going around the shape with the letters. So if I was to label this trap, I would say TRAP going around the shape with the letters. But you would have TA is congruent to RP. And that only happens if it's isosceles. So these legs are congruent. Okay, for the kite, you probably can take a guess at how the diagonals are related here. But there's two things you can say. One is that the diagonals are perpendicular. So the symbol for perpendicular is that upside down T. But marking that in the picture, you can just put a little right angle in the corner. So the diagonals of a kite are always perpendicular. And then two, the non-vertex diagonal, I'll abbreviate that, is bisected. So what that looks like, so the bisected, if it's the diagonal is bisected, that means I can mark that little segment is congruent to this little segment. And that's all we know for the kite diagonals. Okay, turning the page, we're going to go through this number 1 together as well. So it says, complete the following short answers in your own words. What are the differences in a trapezoid and an isosceles trapezoid? What makes trapezoids isosceles trapezoids and kites not parallelograms? So please pause and write out some answers using the notes we just took. Okay, welcome back. So what I'm going to do before I go through this is show you a couple of diagrams to help you sort of solidify what's going on here. So here I have it's called a geometer sketch pad, but we have a geometer sketch of a trapezoid. And these are the parallels as marked. And then if I move this guy around here, you can see those stay parallel. And really the trapezoid doesn't always have to look like a traditional trapezoid. It can be sort of tilted off to the side like this. you can have it so there's a right angle right here. You can make it shorter, you can make it taller. The only thing that matters for a trapezoid is you have this one set of parallels. You can't have two sets of parallels, then it's a parallelogram. Now, compare that with the isosceles trapezoid when I move this around. Notice how it always kind of stays symmetric, they call it. So the left side and the right side always look exactly the same. Always, no matter what I do here. So what that does is creates the base angles being congruent. And also if you drew in those diagonals, so the base angles are congruent. If you drew in those diagonals, those are always congruent as well. So see the difference between doing that and doing this. So very different motions. Okay, and then looking at the kite, same kind of thing you can do is drag one of the points, but notice, and I could drag it up and down too if I wanted to, but notice if I just drag it out and back, those triangles are always congruent to each other. So that angle A and angle C are always the same. And these two little angles here are always the same, and these two little angles here are always the same. Diagonals, when you put those in there, those are always going to be perpendicular. They stay perpendicular. And as A moves out, C moves out. So these two smaller segments are always congruent as well. But because the opposite sides are never congruent for a kite, this can never be a parallelogram. Okay, with that demonstration, I want you to go back to number 1 and see if you can add any more information. So pause and add some more information here. Okay, welcome back. So that is it for the notes. We will be going through the rest of these in class to practice what we have just learned. Good job. We'll see you next time.